Welcome to this tutorial on SageMath for beginners. This tutorial assumes zero knowledge of programming or of Python, which is the programming language that SageMath is based on, and will focus on how to jump in and start doing mathematics right away with SageMath. In this video, we're going to cover the following topics, and timestamps will be in the description, so feel free to jump around. First, we'll talk about getting started with SageMath, either as downloaded on your machine or online from your web browser. And we'll talk through some basic mathematical operations like addition and subtraction, so you can get a feel for how to use SageMath in both of these environments, either downloaded in the console on your computer or online via what's called cocalc.com. But after that, we're just going to proceed on the browser with CoCalc. The syntax is the same regardless, so whichever way you use SageMath, you should be able to follow along just fine. Then we'll take a look at how to use functions, which you can think of like a command with parentheses after it that'll do some task for you, and we'll show you several examples of those and how you can use those to do more complex mathematical operations than just the addition and subtraction, etc. that we show you in the first part. After that, we'll discuss how to import libraries of pre-written code to give you access to even more complex mathematical operations. And we'll use as examples the math module, and then just as an example of how powerful everything can be when you tie it all together, I'll show you an example from this library called matplotlib, which is a sophisticated plotting and graphing library, just to show you an example of how it all can come together, everything that we'll have covered up to that point. Then we'll discuss storing data inside of variables, so you can use that data later, and how you can use this concept of storing data to do some very powerful things. And finally, we'll close with some recommendations for next steps in learning SageMath, and some resources on how to learn more about SageMath and more about Python, which is the lifeblood of SageMath. And then I also have other separate videos that the links which will be in the description. So far I've done plotting and graphing in SageMath, matrices and matrix operations in SageMath, so I won't retread that same ground in this video, but the links will be in the description if you are ready for those more advanced concepts as well. So, let's get started by going to sagemath.org, which is right here. And from this website, you can, if you like, download the most recent version of SageMath, which is SageMath 9.2 as of the release of this video, directly to your computer, or you can also go to SageMath using CoCalc to get an instant Sage worksheet by clicking here. But first, let's go to what would happen if you were to download SageMath. I'm not going to bore you by downloading it because I actually have a copy of SageMath downloaded on my machine already, so I'll just pull that up. And here we see it. Let me get it all into frame there. Okay, now it's all into frame, and as you see, it looks kind of like this. This is actually called the console. See, it says SageMath 9.1 console. I'm a little out of date, but that's okay for our purposes. And the way it works is, you see there's this word Sage, which I didn't type in, that's there already, and with this colon, and after that colon you type, you can start typing whatever you want, right? But what you want to type is a command for the computer to execute. So for example, if you hit 2 plus 2, right? If you just type 2 plus 2 and you hit enter if you're on a PC or return if you're on a Mac, then it will give you 4, okay? I didn't type that 4, the 4 popped up on its own. So I typed in the 2 plus 2, I hit enter, and it spat out that response of 4, right? So that's a very basic example, but you see how it can be very powerful, right? So you can do, I don't know, like 16 divided by 8 or something, and if you hit enter or return, it'll give you 2. So that's what SageMath will look like on the console if you download it to your machine, and this is really helpful if you don't have an internet connection and you can't use it on your browser, or if this is just how you want to work. It's especially good if you want to do something quick, but for the rest of the tutorial, just because it's so much easier to explain things using this, I'm going to use cocalc.com, and you can either type in cocalc.com in your browser, or from sagemath.org, you can just click right here to go to cocalc. And it's going to open up. It takes a second to load, so I'll just pause the recording. Okay, so it loaded, and what it loaded is a sheet, which is nice, but it's like a worksheet, so you can write a script on this, but it's not actually what I'm going to be using. I'm going to be going to a Jupyter notebook, so let's click that. And so you see I clicked Jupyter, and then it gives you a bunch of different possibilities for different programming languages to use. And the one that I'm going to use is, of course, SageMath 9.2, but you see there's a bunch of different ones. But let's click SageMath 9.2, and now it's going to open in a Jupyter notebook. So just to show you one other way to do that, in case that was confusing, is let's close out of this and go to open up cocalc.com directly so you can see it a little more organically. So here we are at cocalc.com. I just typed in cocalc.com, and you can make an account, of course, if you want to save your work, but no need. You can just click Run Cocalc Now, and it'll load. So I'll pause the recording because just to give it a second to load. And then once again, here we are at the same page we were before. To pick whatever language you want to write in, it'll be SageMath 9.2, and here we are at our Jupyter notebook, and that's Jupyter Jupyter, and so that is this way of executing blocks of code in this cell-by-cell format, which I just find is the best way to do tutorials. So I'm going to zoom in a touch just so you can see what I'm doing, and we are ready to roll. So we saw a couple of the basic mathematical operations earlier, in essence just using SageMath as your calculator, but let's just run through all of them. So let's start with addition, 3 plus 4, right? Subtraction, 3 minus 4, multiplication, 3 asterisk 4, asterisk for times, okay? And then division, 3 divided by 4. And let's see. So in order to run a cell, you can click on that cell, okay, inside this box, and hit Shift Enter on a PC, or Shift Return if you're on a Mac. So I hit Shift Enter, and it's going to evaluate what I just put in, and it takes a second when you first start it. I promise it's not always this slow. Well, I stopped the recording just to see if there was an issue, but there wasn't. It was just being slow on me. So, okay, so 3 plus 4, and it gave me 7. And you can do this one by one, Shift Enter to run, and now it's going faster, okay? But you can also run all the cells by going to Cell, and then run all, and that'll run all of the cells, okay? And so this does some pretty interesting things. You can see that we have 3 plus 4 is 7, 3 minus 4 is -1, 3 times 4 is 12. 3 divided by 4 actually keeps it as a fraction. When you divide integers in SageMath, by default it'll give you a fraction if it can. So if you wanted this to display as having a decimal value instead, you can add a decimal point to one or both of the numbers, like so. If it's 4 with this decimal point, and then you run that cell, now it's going to give you 0.75 with a bunch of trailing zeros. You can get rid of those zeros with what's called a function. I'll show you that a little bit later in the video. But now, for now, suffice to say, if you are content for this to stay a fraction, it can be a fraction. Otherwise, you can make it 4.0 or even just 4 point, like that. Okay, so there are certainly other operations that you can do. We have a few more. Let's do exponentiation. There are 2 different ways to do that. You can do 3 * 4 for 3 to the power of 4, or 3 caret for. This little caret, shift 6. For the caret or the asterisks star star, it'll give you the same result. And notice this is a difference between Python and SageMath, because in just typical Python, this would not work. This is the notation in Python, 3 star star 4. But in SageMath, either of these will give you the same thing. It's exponentiation, 3 to the power of 4. There are other operations to show you, but right now I have all these cells in my Jupyter notebook that I'm done with. So one trick to delete all these cells, since I want to clear everything, is you can just click one of the cells, the whole cell, not just the box, and you can actually just hit DD on your keyboard, and it'll delete them all out. Okay, so that's one quick thing to do. You can also hit escape, select the cells to clear, and hit DD to clear them all as another way to do it. So you'll see me clear these out from time to time. So another operation to mention, and it has to do with division. If you took, well, actually there's a few more, and they have to do with division. If you took 10 and divided it by 3, what would you have? You would have 3 remainder 1, right? If you recall long division, you can divide 10 by 3 times neatly, right? And so it gives you 10 divided by 3 like this, or it gives you 3.333 repeating like that, like we've seen before, but it gives you 3 times neatly, because 3 times 3 is 9, and then you have kind of 1 left over, right? So you would have what's called an integer part of 3 and a remainder of 1, right? It's 3 remainder 1. But if I just type in this 10 divided by 3 with the decimal, right, it just gives me 3.333 repeating, which isn't that helpful. How do I work out what the remainder is if I wanted to do the remainder, or what the integer part is if I wanted to do just the integer part? Well, if you want just the integer part, you can do what's called floor division, so dividing and just getting that integer part, cutting off the remainder. You do that with 2 slashes, so 10//3 like so, and that just gives you the integer part. If you wanted just the remainder, you can do the modulo operator, which is a percent sign, like 310 modulo 3, okay, and that gives you the 1. So you see you have the integer part of 3, the remainder of 1. This modulo operator is going to be very, very useful in programming in general, so it's something I wanted to show you, though, you know, you might not be using it all the time for math, depending on what you're doing. You'll also notice that the cells will display an output at the bottom. You see how it says out with 3 or out with 1, right? But what if you had a bunch of different operations all in one cell, like follows? So what if you had 2 plus 2, 18 divided by 9, 8 minus 7, okay? Notice that before now, I've been putting everything in its own cell, and that was on purpose, but now what happens if I put all 3 of these into one cell, one line followed by the next, and I just run that cell? It only gives me 1 when I run the cell. And that's because it's only going to display the very last output. And that's because this is a Jupyter notebook, okay? And that's a little different from the console that we saw before, where it was downloaded to our machine and we would hit enter, and it would just evaluate whatever you gave it. Because we have these cells in our what's called Jupyter notebook, you know, we have just this last line displayed, right? And so how do you get the rest of these answers displayed? The answer is to use a programming function that will display them. So that kind of transitions me to talk about my next topic here, which are functions. And functions in programming is not the same thing as a mathematical function, like if you see like function of x equals x plus 1 or something. It's not what we're talking about. In programming, a function is some pre-written bit of code that you can use to perform a certain task. And in SageMath, just like with Python, The functions are typically a word or a phrase connected by underscores, or a word followed by parentheses. And once you get more comfortable with Python, you can write your own functions, but SageMath actually comes with a large number of functions that can perform different mathematical tasks for you that are built in, they already exist. And the first function I want to show you is called print. So, print can display the output on your screen. It can display as output whatever you put inside these parentheses. So if you do print 3 plus 3, and then you run the cell, shift enter, it will display 6. Okay, so see how the syntax works here. You type the name of the function, the name of it, which is print, parentheses, no space, just parentheses right afterwards. Then inside the parentheses, you put what you want your function to work on, which is called the argument, okay? It'll do the math first. First it'll do the 3 plus 3, and then it'll display the result, okay? And so you see a subtle difference here. There's no out colon, it just prints it, all right? So this is how we solved the issue we had before in this cell up here, where the 2 plus 2 and the 18 over 9 weren't displaying, okay? We can do print. And I'll just do it for the first two so you can see what happens. If you hit Shift Enter, you see now it gives you 4, 2, and 1, all right? Now, a Jupyter Notebook is always going to display the last thing you put in it, in the last line, all right? Unless you suppress that with a semicolon. Now it's just giving you the 4 and the 2. This one is suppressed. This 8 minus 7 is no longer going to display. What happens... Now remember, when we did this before, it had the out. What happens if it's all just print? Note the subtle difference here. It no longer says out because it's not just displaying it as an output. It's doing your command. It's printing these. You know, and the word print, I mean, I guess it dates back to when people would have to type into a computer and literally print out something on a piece of paper to see the output. Thankfully, we're in a time now where it will just display directly on your monitor, like so. So print is a function that comes straight from Python 3 and can certainly be used to display more than mathematics. I would be remiss if I didn't show you this. If you wanted to use it to display text, you can put that text inside quotation marks. And this is just straight from Python. Like so. This is a classic example where if you put text or you know, symbols or numbers or what have you inside quotation marks, it'll make what's called a string, which isn't super important for the purposes of this tutorial, but will be very important if you advance with Python. It's a key concept. It's kind of like plain text. You know, a string is what's inside these quotation marks, all right? And so this prints out hello world, which if you do a Python tutorial later, which I strongly recommend that you do if you're going to be working in SageMath, you'll certainly see print hello world as probably the first thing that they show you. Okay. But SageMath is a lot more than just Python, so I wanted to also share with you an example of a function that is not built into Python, that you would have to import if you were going to use it in Python, import from a library, which we'll talk about later, but in SageMath you don't have to import it because it comes built in. So there's a bunch of examples of this. There's all kinds of complex math, but I'll show you a relatively simple one, and that's factorial. So factorial, see how the syntax is just the same as print. It's the name of the function followed by parentheses. And what goes inside the parentheses, the argument. In this example, it's just one argument that'll go inside. It's the number that you want to take the factorial of. So if we just do 4, right, if we put 4 inside, it'll be 24, which is much faster than if we were to write out 4 times 3 times 2 times 1. It'll give you the same result, 24, but you know, for if you just use the function, it has the big advantage because it's you know, you won't make a mistake like you might if you were typing out 4 times 3 times 2 times 1, and if you do a bigger number, you couldn't even type it out if you wanted to, and it would be very prone to error. So if you wanted to do factorial of like 11 or something, I mean, you could go even higher, but these numbers get very, very big very, very fast, so I won't go too much higher than that. But a factorial of 11, and bam, it just does it right for you. You don't need to type out 11 times 10 times 9, etc., right? So the factorial function is just one of many, many functions that are available in SageMath. It would take us all day to go through them all, which I'm not going to bore you with, but I do want you to understand how the syntax of these functions work. So in the interest of showing you more of the syntax, there are functions that take more than one argument. An example of that is round. If we do round of, some number, that's a bad example. If we do round of some number, right, comma 3, this has 2 arguments. In this case, it's taking the first argument and rounding it to the number of digits specified in your second argument, right? So you see it rounds it to 3 decimal places because we set it to 3. If I had made it 4, well, that's a bad example. Yeah, that was a bad example because the 4th digit was a 0, so it wasn't going to display it anyway. But if we do 5, then it's going to give it to us in, the 5 decimal places, right? And so, if you want to do round of 3.14159 whatever, the 5, 3, okay, to 3, it's going to give you, just 3.142, right? Or if you do 2, right? So anyway, but that's not obvious from just looking at this, at this function. It's not obvious what it's going to do unless you already know, right? But it's not something you need to memorize. You can go back to the documentation for SageMath, the documentation for Python 3, the links of both of which will be in the description, right? Because they're just on the websites of those, entities of Sage and of Python. And those will tell you, hey, this is what the function is, the built-in function. These are what the arguments are that you can put into it and what you're instructing the computer to do by putting this in, right? So in addition to arguments, there are also some things that can go after arguments called keyword arguments, depending on the function, and you can use those to modify or specify exactly what you want to do. These are usually written out with some keyword followed by an equal sign and then whatever it is that you want. And again, they're not going to be necessarily intuitively obvious. They're going to be something that you can look up. You can Google it. You can look it up in the documentation. But I'll just show you an example. So remember before when I showed you 3 divided by 4 with a decimal and it gave us this crazy string of zeros after the 0.75? And I told you there would be a way to bring this down to only 2 digits. You can do that. You can do that with a function. There's a couple of functions that can do that, but one that I'm going to show you is just the letter n. And the letter n, lowercase n for numerical approximation, and parentheses, and inside the parentheses, your first argument is this 3/4 decimal, right? It's what you want it to be. And then the second argument is the number of digits, or it's actually a keyword argument, is the number of digits equals, and then let's just say 2, okay? And that's going to be the number of digits. So let's run it. And you see it gives you your output is just 0.75. And here's actually a difference, and I'm glad that happened earlier with the rounding, because that rounding, it cut off the 0. But here, if you do digits equals 3, it's actually going to keep that 0 in, right? And this just tells you how many, digits you want it. Again, it's not so critically important that you know exactly how to do this exact function. I just wanted to show you this is what a keyword argument looks like. And you'll see these come up time and again in different functions that can do different things. It's this word followed by an equal sign. Okay, you see it comes after the comma. So what we have is we have our argument, the 3/4 with a decimal, right? Comma, and then our keyword argument, which is the number of digits that we want. And that is how you can get rid of all those trailing zeros as well. It's one way to do that, at least. Okay. So while SageMath has a lot of functions built in, there's also a great number of functions that are not built in per se, but still exist in other libraries. And you don't need to separately install anything, but you do need to import them from other libraries. And I'll show you what I mean by that. What you do is you can just import a set of, and it's not just functions, but all kinds of things, by typing import and then the name of the library that you want to import. So let's do math for something called the math module. And this is a Python module. And I actually have, I believe I have a whole playlist of videos on different things in the math module. It's all the same. That playlist is for Python, but it's all the same. So I'll put a link to that in the description. So I won't belabor what all that's in this math module, but if you import math and then you run the cell, now you've instructed it to carry out the instruction to import math. And now that we've imported math, we can use anything that's in the math library, which includes a number of additional functions. And one example is this function called hypot. Okay, and so the way that we do this, and so hypot is going to take two arguments, two sides of a right triangle, and it'll spit out the hypotenuse. And I'm not showing you that because it's so critical you know that specific function. I just want to show you the syntax. And so, as you'll see, what I did is I wrote the name of the library that I imported, math, okay, dot, and then the name of the function that I wanted to use, in this case, hypot. And as mentioned, it takes two arguments, the two sides of a triangle. So in order to use it, since we've imported math, first we tell SageMath that we're going to be using something from the math library, and that's with this math. Then we want to tell SageMath the name of the function we want to use from the library, which is hypot, so math.hypot. Then, inside the parentheses, we put in the arguments that we wanted to analyze, which is going to be 3, 4 in our case, so that we have a right triangle with sides. One side is 3, and one side is 4, and what's the hypotenuse? It's 5. Okay, and that's just telling us that 3 squared plus 4 squared equals 5 squared, a 3, 4, 5 right triangle, which you might have seen in other contexts. Much faster and easier than doing the Pythagorean theorem yourself. You see how this can be very powerful. Because it doesn't have to be such a clean 3, 4, 5 triangle. It can be, 16 and 4.604 or something, and it'll tell you, what the hypotenuse is, right? So that's that's just a nice way. So that's one example of one function out of many, many functions that exist in this math library. But you can import math and then math dot whatever it is you want to use is one way to do it. But I want to also tell you two other tricks, two other ways to do it with import statements. One, you can give whatever you're importing a little nickname. So instead of import math, you can say import math as M, all right, and then run that cell. And then here, let me just clear this out. Import math as M. And so what does this do? This tells me I'm importing math, but I'm not going to have to write math.math.math. I can just write m dot because I've given math a new name. I've given it a shorter name, m, okay? So that you'll see that sometimes, and then you can do m dot hypot, 3, 4, and it'll work just fine. It'll give you your 5. Okay. Another trick is that you often will not want everything from the library. Some of these libraries are quite large, and in this case, we're only doing the hypotenuse, right? We only need one thing. We don't need to import the entire math library to do it. So instead, what we can do, and I'm just going to clear this all out so we can start fresh, is we can just do this. From math, import hypot. And now what does this do? This is saying, hey, go into the math library and just import this one thing from it, HiPot, and take it, and I can use it now as HiPot. I no longer need the math dot or the m dot HiPot because I have imported it directly. I've yanked it in, and now I can just do HiPot 3.4. I don't need the math dot. See, it works fine. Okay. You can certainly, sometimes you'll see from math import asterisk, and that's like a from math import all, and that way, that's one way that you can get it so that, you know, you're importing everything, and you don't need to do the math dot because you've imported everything, right? And so that can be useful, but depending on what you're doing, it might not be the best move, because now, one, you'll have a bunch of functions and things imported that you're not going to use. Two, it might not import everything. There's some packages like SciPy that are too big. So if you import all like this from SciPy import asterisk, it won't actually import everything the package has to offer. It's a trap for the unwary. And, you know, so your mileage may vary, but it is also an option, and you will certainly see it. Okay, and so now I want to do something a little fun, because speaking of packages, there are a great number of packages in SageMath that can do even more complex and interesting things, several of which don't come pre-installed with Python. They're available in Python, but you would need to separately install them yourself in order to use them. But in SageMath, a lot of them, these are already installed. So one example that I want to discuss quickly is Matplotlib, which is a very powerful plotting and graphing library, and it's already installed. And this isn't a Matplotlib tutorial, which I do hope to make at some point soon, so I won't belabor how Matplotlib works, but I want to show you an example of how all this syntax can come together to make something a little more complex. So what you can do is you can type in from Matplotlib, import pyplot as plt. Not important for purposes of this tutorial that you memorize this phrase, okay? I just want to break down what it is that I'm doing. Remember how I had before from math import hypot, you know, for hypotenuse? Well, here I'm combining it all together. I'm doing from Matplotlib, so the library that I'm importing from is Matplotlib. Import pyplot. Okay, pyplot is a thing that I'm taking from Matplotlib, and it's the only thing that I'm taking. I'm not importing all of Matplotlib and everything under the sun. I'm just taking one thing, which in this case happens to be something called pyplot. And I'm giving it a nickname, PLT, because I don't want to write pyplot. I just want to write PLT. So from Matplotlib, from the universe of things in the Matplotlib library, import this one thing, pyplot, which is a plotting function, basically, or a plotting tool, as PLT. But I'm going to call it PLT. So every time I want to use pyplot from now on, I'm just going to call it PLT, okay? So Shift-Enter to execute that so that the computer knows to do that. And now it's done that. So now here's where all the syntax can come together. You can do plt.plot. Okay, so remember I imported pyplot as PLT, so in this case I took PLT, and I'm going to do plt.plot, and plot is the function within PLT, and then it's going to have some arguments and some keyword arguments. And let's do 3, 4. This is going to be a point at x coordinate 3, y coordinate 4. Those are my arguments. Marker equals, and let's do this, and that's a keyword argument for I want my marker to be a triangle. Color equals red. Okay, and there's a couple different ways to do this, but I'm going to make it a red triangle at point 3, 4. All right, and so let's run it, and you'll see how powerful all of these concepts are when they all come together. And there it is. There's my triangle. It is at 3, 4. It's a red triangle. It's exactly what I wanted it to be. So you see how now I have plotted something using all of these concepts. I've taken something, I've imported it, and I've made this function. It has arguments, it has keyword arguments. Do you need to memorize this specific thing? No, you can look it up. You can Google it. Matplotlib has excellent documentation, and it'll explain exactly what each of the arguments are and each of the keyword arguments are in order for you to do whatever it is you want to do. Now I want to shift gears a bit and talk about variables. And I don't necessarily mean variables in the math sense of the word, but in the programming sense of the word. Variables are a means to store data, and that'll make more sense as we go through them. But it's essentially a series of letters, underscores, that represent some data. That data can be text, a number, what have you. So, for example, if you do my variable and then equals sign 2, all right, and then you run that, it's going to now store 2 into my variable. Okay, so if I just want the output of my variable, it's going to give me 2, right? So there's a couple of these that are built into SageMath already. So for example, if I wanted to use pi, instead of typing out the digits of pi, I can just write pi as the word pi, and it'll display out, its approximation of the digits of pi, right, as my output. And you can see how this is very powerful. For instance, if you know that the circumference of a circle is pi times the diameter, right, then you can write pi times, 3 or something as the diameter of pi, and as the diameter of pi, as the circumference of the circle, and there it is. It'll give you the circumference of the circle. Okay, so these pre-built variables are all well and good, but things get really powerful when you start making your own variables like we did up above. And as mentioned, you can do that by writing the name of the variable you want. It can be any name, just no spaces, and it can't start with a number, but it can have a number in it later. And it can have underscores if you want multiple words. That's fine. So like my underscore variable, for example. And then it will store it. Okay, so in here we have my variable equals 2. Let's try another one. So if we have cool num equals 40, right, then if we wanted to do cool num times 4, see, it just plugs in the 40 because this cool num is now storing 40 inside it. Okay, and so that's really nice. As a best practice, though, cool num might not be the best variable. You'll want your variable to be something that's a little bit descriptive of whatever data is being stored inside of there. So going back to my earlier example of a circumference being pi times the diameter, say you wanted to be able to change the diameter of your circle and quickly see how that changes the circumference. Well, you can do this by making a variable to stand in for your diameter. Let's call it diameter. And let's make it 3. And then let's do another variable called circumference, which equals pi times diameter. And so then to display this end result, let's try this, print circumference. Okay? And there it has it. And so what's going on here? We printed the circumference, which is pi times the diameter, all right? And sorry, I just wanted to check something. If you find yourself getting just 3 times pi here, which is what I was expecting to get, to be honest, I'm not sure why I'm not. But if it's still retaining its symbolic form, 3 times pi, then remember you can do that n function we had before. Digits equals however many digits you want. And what would happen here? Then it would give you, just it would just give you the digits that you wanted out of this because you're using this numerical approximation function. So that's just one thing that you can do, especially if you're still getting it in a symbolic form in pi, if it's just showing up as 3 times pi. Okay. So, but in any event, that's a bit of a digression. The more important thing is to know that you can store data inside variables. It does not have to be a number by any means. I was showing you numbers because you're probably mostly interested in SageMath for mathematics, but it can certainly be, something like hello. If you do 7 equals this, 7, if you do s equals this string hello, right? And then now you have it. Okay, so it can store something like text like that. All right. Okay, so finally, as we're wrapping up this tutorial, I wanted to give you some thoughts on next steps for you. This was a tutorial with non-programmers in mind. I just wanted to give you an introduction to SageMath and how it works and what it looks like, some of the things you can do in it. But this is just scratching the surface. SageMath is incredibly powerful, and at its core, it's a programming language. And in fact, it is generally based on the very widely used programming language Python. So I have to say, if you learn some of the basics of Python, then SageMath won't be any trouble for you. There are just a ton of resources available to learn Python. If you're especially looking at YouTube tutorials, there's some good ones at the Free Code Camp channel that are free. They have a number of highly regarded Python tutorials. I would recommend looking into, in Python, how to make your own functions, how to do if-then statements, how to make loops, how to get input from the user. All of those things in Python carry over very directly to SageMath, okay? I would also be remiss if I didn't plug some of the other videos I've made that go into more advanced concepts with SageMath, including plotting and graphing, matrices, and how to get help/other resources when you're stuck. The links to those will be in the description as well. There are also several free books out there about SageMath, and I'll put links to those in the description as well. One that I highly recommend is Sage for Undergraduates by Professor Gregory Bard, which he is kind enough to, at least as of this video, have put on his website for free. So we'll definitely put a link to that in the description as well. And with that, I want to thank you very much for watching this tutorial through to the end. I hope it was helpful to you. If it was, please do give the video a like. It makes a big difference and is an easy way to show your support. There will be more SageMath content to come, so if you're interested in that, please do subscribe as well. And thanks very much for watching.